Hi friends, welcome to Watch Science Channel. This modern knowledge is the shortcomings of modern science, and to talk about gaps. That's why this video talks about a small flaw in Albert Einstein's theory of relativity. Friends, many of you already know that a massive star dies in a supernova explosion. Then the star's solar gases are thrown out. The core of the star gradually starts to shrink around its core. So, in this way, when the core of a star gradually shrinks, electromagnetic forces are activated inside it. That electromagnetic force creates so this star's contraction gradually slows down. At some point, it's stabilized. That's when we called a neutron star. But in any case, if this is a little big star, or the core of this star is very big, it overcomes the electromagnetic force and starts shrinking gradually. Then only gravity works here. Because of this, these substances are continuously shrinking. So, this is where a singularity is formed. At a time like this, due to this gravitation, the matter in it shrinks to infinity. This is what we call a black hole. So, in the vicinity of a black hole like this, space-time is very strongly curved. That means it curves to infinity. Then even light cannot come out through that space-time. So here we always come to use the word singularity when describing black holes in this way. And we have to use the word infinity. When we see words like this, we can understand that there is something wrong with this theory. So, the first thing we need to understand here is that the mass inside the core of the star is still inside the black hole. Because the mass remains there, a very large gravitational field is there. However, we still have not been able to explain how this amount of matter exists inside this black hole. That is why we use the word singularity. And this uses the word an object that shrinks to infinity. So from this, we can understand that there is a very large amount of matter, including a black hole. We feel its gravity, but we don't know what state these substances exist in. We are only within the words singularity, or an object that has shrunk to infinity. But in fact, this is our ignorance. At the same time, you can understand that Albert Einstein's theory of relativity does not describe the situation inside a black hole. There is a big drawback there. So how do we untangle this mess? So, in order to solve this problem, we need to think about the atomic state of the matter inside the black hole. That's why we need to think at the subatomic level. This is where we need quantum mechanics. Everyone has heard about Max Planck, the scientist who first proposed everything in this universe. It is divided into small parts. That small part is called quanta, as the space and time are all divided into small parts. The smallest distance we can measure in the universe is considered to be Planck length, which is very small as Planck. Here we have 1.6 meters times 10 to the power minus 35. Then you can imagine how smaller it is. And as Max Planck said, nothing smaller than this can exist anywhere in this universe. So if we think about using this theory, the amount of matter in a black hole shrinks due to gravity. But it can never shrink more than this Planck length. There is no way to shrink it to infinity. So, when you listen to these details, you will understand how many contradictions there are between relativity and quantum theories. So, I told you only one case. There are many more such cases. So, because of this matter, some scientists have presented several theories about how a black hole can be formed in a way that does not go against the theories of quantum mechanics. I will tell you one of them. So scientists called it the Planck star. What happens in this case is that a big star explodes and its gases are thrown out, and the core in it will gradually start getting smaller. But in any case, according to this theory, this amount of matter does not shrink to infinity. It stops at a place larger than Planck length and stabilizes. That's what we call a Planck star. So, after hearing these details, if we compare the black hole with the Planck star that we are currently considering, if we compare it externally, we will not be able to find any difference between these two. But if we look inside this black hole, we will be able to see this difference. However, this new theory, too, has problems. When this amount of matter shrinks at this speed, only gravity works there. So then how can these substances stop this contraction and stabilize at a point greater than a Planck length? At the same time, you may understand that in such a situation, electromagnetic forces are not sufficient to stop these gravities. Therefore, if this is correct, it should shrink till infinity if possible. But as Max Planck said, no object can be smaller than the Planck length. So, this means that if a Planck star like this is made, there should be a force that we have not known for so long, and it should work against gravity. Then this Planck star can be stabilized at a certain level like this. But what is that force? What is that energy? We still don't know the answer to the question, and we don't even have a theory to satisfy this situation. But sometimes, one day in the future, scientists can find out some clue or theory to understand this. So, after hearing all these details, you will understand. When we describe a black hole, we cannot use Albert Einstein's theory of relativity. It has its flaws. New theories have come to replace its shortcomings. There are new flaws in those theories. So, as I have described, there are many shortcomings in human knowledge. There are many undiscovered areas. Try to see if you can add new knowledge to such a thing. All of you know that in the age of information technology we are living in, we were able to make this kind of information technology because we learned how to make the electromagnetic waves the way we want and control them the way we want. So, if there is any new power working inside the Planck star that I talked about before, if there is a power working that we don't know, if we learn about it and start to control it, then we will be able to create new technologies, and we can do a lot of things that we have never done before. It will enable us to do unimaginable things. So, after listening to all these details, you will understand even how great the scientist Albert Einstein is. And no matter how intelligent he is, there are some flaws in the theories he made. Thanks.